Now we're moving on to probabilities with the word or rather than the word and, separating our two events. And so to find that probability, we're going to have to find these three probabilities first. And so let's go back to example A, which is the example with the 100 employees and whether or not they were in favor of working 4 days a week. And so here the first one is asking us to find the probability of either being in favor or male. And so I'm going to make all the substitutions. And so the first thing I want to find is the probability of being in favor, and then I'm going to add the probability of being male. And then I'm going to subtract the probability of being both in favor and male. And so real quick, let me explain why we subtract this piece right here using these 3 employees that I've made up on the side. And so you have Alex, who's in favor of working 4 days a week and is female. And then you have Bob, who is in favor of working 4 days a week and he is male. And then you have Charlie, who is against working 4 days a week and is male. When I calculate the first 2 probabilities of this formula, notice what happens. So Alex is going to go into the probability of being in favor, but she's not going to go into the probability of being male because she's not a male. Charlie is not going to go into the probability of being in favor, but he is going to go into the probability of being male. So both of these people, Alex and Charlie, are only being counted once, which is what you want. But look what happens with Bob. Bob is in favor, so he's going to be included in that probability, but he's also male, so he's going to be included in that one as well. But you only want one person to be counted once, and so here, you just have to make sure that you remove one of those extra Bobs with this last probability. And so this is just making sure that we don't have any duplicates and that we're not counting anybody twice. And so that's why you need to subtract the probability of A and B, or in this case, I and M. And so moving on, we can actually find each one of these 3 probabilities. And so the probability of being in favor, that's 19 out of 100. The probability of being male, that is 60 out of 100. The probability of being both in favor and male, and so again, in favor, male, is 15 out of 100. Since all of these fractions have the same denominator, I can just work with them, and so 19 minus 15 is 4, so this is going to be 64 out of 100, or 0.64. Part B is asking us to find the probability that one person is either in favor or against working 4 days a week. And so I'm again going to have to use the formula. So I'll first find the probability that somebody is female, then add the probability that somebody is against, and then subtract any duplicates. And so the probability that somebody is female, that is going to be 40 out of 100. The probability that somebody is against is going to be 81 out of 100. And so real quick, before I continue this example, I want to point out what would happen if I accidentally forgot to include this piece, if I just accidentally did not subtract my duplicates. Then here, what I would get as my probability would be 121 out of 100, which would equal 121%. And our rules of probability tell us that this is not possible. And so that's why we absolutely need to make sure that we're subtracting this third probability every single time, because that just removes any of those duplicates, right? And so what this means, getting a probability greater than 100%, means that you counted people twice, or more than twice, depending on your example. But so here, to continue this example, the probability of being both female and against is going to be 36 out of 100. And so this is going to equal 85 out of 100, or 0.85.